Uday Khodke sir. Today's speakers, Dr. Saeed Ismail sir, Director SIFA Sanpra Systems Private Limited Mumbai and Consultant NABARD, and Dr. Ajay Sharda sir, who is working as professor at Kansas State University, Manhattan, USA. Dr. Santosh Pitla sir. I welcome all the dignitaries. Thank you, sir. Once again, a warm welcome to all the dignitaries. Today, we have Dr. Saeed Ismail sir, Director SIFA Sanpra Systems Private Limited Mumbai and Consultant NABARD, and Dr. Ajay Sharda sir, working as professor in the Department of Biosystems and Agricultural Engineering at Kansas State University. Now I would like to request Honorable Vice Chancellor and all the dignitaries. I request all the dignitaries to please take their seats. Honorable Vice Chancellor, Dr. Indramani sir, respected Dr. Khodke sir, Director of Instruction and Dean, Faculty of Agriculture, VNMKV Parbhani, Dr. Saeed Ismail sir, Consultant NABARD, our next speaker, Dr. Once again, I warmly welcome all the dignitaries and the participants present over here for the morning session of the second day of this international workshop. Yesterday also, all the participants, they were benefited by the very excellent lectures delivered by Dr. Santosh Pitla sir and Dr. Jha sir. I hope all the participants, they will be benefited for planning their future research work. And today also, we are fortunate to hear Dr. Saeed Ismail sir, Director SIFA Sanpra Systems Private Limited and Consultant NABARD, and another speaker, Dr. Ajay Sharda sir, who is working as professor in the Department of Biosystems and Agricultural Engineering at Kansas State University, Manhattan, USA. Okay. I would like to request Dr. Honorable Vice Chancellor sir to welcome our today's speaker. Just welcome sir. Yes. Dr. Saeed Ismail sir, I request him to welcome Dr. Saeed Ismail sir. Once again, thank you, sir. Once again, I request Honorable Vice Chancellor Sir to welcome Dr. Ajay Sharda Sir, Professor in the Department of Biosystems and Agricultural Engineering at Kansas State University, Manhattan, USA. Dr. Ajay Sharda Sir, our today's guest speaker. Bouquet aane. I also request Dr. Dean Uday Khodke sir to offer bouquet to the Santosh Pitla sir. I request Honorable Vice Chancellor Sir to guide the participants present over here.
Friends, very good morning to all of you. And we started this program yesterday, and today we have very good speakers, two good speakers. Dr. Syed Ismail, a very good friend of mine, senior friend, and almost we are associated on different platforms, and I found him a wonderful scientist, straightforward technologist, and person who worries about Indian agriculture always. Since morning to evening, he just talk and try to tell people that what should be the direction of agriculture, research and technology development if you really want Indian agriculture to develop and Indian farmers to be happy. So we have, as I said, that we are associated in Indian Society of Agricultural Engineers. We are associated together in Asian Association for Agricultural Engineers. And recently we did a great event of international symposium at Aurangabad on behalf of Asian Association for Agricultural Engineers. So very warm welcome Dr. Syed Ismail for this, and he has been guiding to students and younger faculty, even from Rahuri, and TNAU and many other universities. He's consultant to NABARD, and we had him here during DST workshop, and again a very short notice we disturbed him that we want you here, and he agreed to come, and he stays in Mumbai, so simple train ticket works and he come here. He is a he is, I will say, not costly expert. So really, but very much enthusiastic. Then we have our friend Dr. Ajay Sharda. In fact, he was very busy. He came here, from US with family, and lot of meetings are there. We are actually, we were close for another reason. His mentor and my mentor was the same person, and whenever he used to talk to me, he used to discuss about him, and whenever he talked to him, he used to discuss about me. He was a great scientist, technology, wonderful person, a poet. But recently, on the 12th of December, he joined his heavenly abode suddenly. And that was a great jerk to me and to him also. So I said, told him that if you come here, despite your busy schedule, at least we can share the sorrow and we can share the happiness of the university. So for that, he spared time and we could have some moments, you know, and personal discussion about our mentor. And Dr. Sarda is a very hard worker. You know, I have visited his lab and see he is very, very young also. And good thing is that he started his career from Parbhani and Nanded area. He was with the Scots. So he is aware of the situation and requirement of this area. He did his BTech in 1998, you can understand, 1998 from PAU Ludhiana. 2001 he did his master's from there only, and PhD he did with our university, Biosystem Engineering, USA. And he is a very known person in the US machinery and tractor industry, a very known person. It's basically all kind of approval and other things and that those goes from his table and from his lab. A very wonderful lab, and two of my students, our students are currently in his lab. Datta Patil and other gentleman, both are there and getting trained under him. And I hope and wish that many more people should get opportunity to be there. He's in Kansas State University nowadays, and wonderful work he is doing. And we all were discussing, gentlemen, boys and girls, that it is basically, it is your luck that you get a tough person, tough boss with inner good heart in your life. So, and take life very, very seriously, you know. So that we were taught by our teachers, me, Sayyad, these all who are sitting here, they all have been taught by their teachers that no replacement for hard work, no replacement for hard work, and no replacement for dedication. You have to learn not only the technology which they are going to discuss. From their, biodata, they were like you, he was roaming here in this district and Nanded as a man of his Scots tractors. And now from there, he is guiding the United States of America tractor industry, that what you have to do, what standard you have to maintain, and all those in a very short span of time. So always try to understand that बड़ा होने के लिए, बड़ा काम करने के लिए कोई उम्र नहीं चाहिए. जरूरी नहीं कि जब आप बूढ़े हो जाएंगे तभी आप बड़े काम करेंगे. Dr. Sayyed, Dr. Sarda, my father used to scold. जब भी कहो उनसे कि तो वो कहते थे, एक एग्जाम्पल दिया करते थे, अकबर 14 साल की उम्र गद्दी पे बैठा था. व्हाट डू यू टॉक अबाउट? मतलब उनका कहना था कि अकबर 14 साल की उम्र पे गद्दी पे बैठा था. ही टुक रेन ऑफ द कंट्री. अब आप बताते हो कि अभी 20 साल के, 25 साल के, 28 साल के हो गए, अभी काम करने की उम्र नहीं हुई. तो ये एक बड़ा ज़रूरी है कि आप आजकल के ज़माने में हार्ड वर्क इज द एंड सूझबूझ के साथ काम करने का. And then always I tell you, to my dear students, that transparency, honesty, good relationship, big heart, larger sheep size, these are the essence of, life, if you want to, and try to keep always in your mind that, focus, positive energy, don't get distracted. Don't get, everybody in the society will try to distract you. This is your capability, don't get distracted, remain focused. Learn how to avoid, just getting influenced from the negative energy. Those are the things which I always talk to my friends and as a Vice Chancellor, that should be, something which cannot be, is not written in the books, should be taught to you in the, campus. And for that, I always try to interact with you, meet with you, and bring people like Dr. Sarda, Dr. Syed, Dr. Santosh, and yesterday Prakash Jha. Just last week we had NRM top people of the country. They came here, we had interaction. ASRB member we brought here to have interaction with the students, separate interaction with the students. What is this JRF, SRF, ARS, and all those things. So my job is to, provide opportunity. Your job is to grab the opportunity, to take advantage of it. And that will give satisfaction to me, and satisfaction is always which boost positive energy to do something more and more. With these words, once again I welcome all the guests here, experts and all my friends, faculty and students, and request the organizers to go ahead with the program. This is the second day, so make best use of their presence and of their knowledge. And you do try to interact, ask some questions. There must be some kind of darkness in your mind. Try to dispel that darkness from your mind by asking questions. Because until unless you ask and you identify your darkness, they will not be able to throw light on those darknesses. My dear friends, life is to learn from all. Life is to learn from others. Life is to learn from who have lived more life than you, and try to get that's what I'm saying. Dispel the darkness, and how to bring light in your life. And finally, try to live a very, very a happy life. I told you, in this university, since beginning I'm just telling you, life minus happiness is equal to 0. Anything you have, if you are not happy, then everything is 0. Everything is 0. So many times we are not understanding, and we don't see the future. That anything, any action, any plan which you are doing, what is its effect on your future? So both try to do justice with your personal life and professional life, and become an important citizen and serve the society. If you are not able to serve the society, your life is not successful. So always keep that in our schedule, day-long schedule, what portion, what action has benefited the society. And society may be just around you, or larger society, smaller society, but to try to do. I always try to share these thoughts with you, and in front of my friends again. Yesterday I was here, then day long I was busy on farmer's field and in KBK, but I had to come here and meet my friends and present them before you, and tell you that learn from their life, from their efforts, and become better than us. Try to become better than us. We never say that be like us. हम तो छोटा ही मानते हैं. बहुत कुछ करना चाहिए था, बहुत कुछ और कर सकते थे, और बहुत कुछ करेंगे, करते रहेंगे. ऐसी प्रॉमिस, जब तक श्वास है, जब तक जिंदगी है, तब तक हमें काम करना चाहिए. But spread happiness around you, and try to always learn from better people, good people. With this, thank you very much once again, and once again I welcome our guests to this campus. I have already told you this is a very big university, in such sense spread over 8 districts, more than 100 small and big institutions, had more than 100 years of history to be here in Parbhani. Our first research station on cotton was established in 1918. So we have 105 years, journey as a research establishment, and 52 years journey as a complete university. And let me tell you, around this also from 1956, we are a college of agriculture. And in the beginning, we were with the Osmania University, and this is part of Marathwada. So we have Dr. Santosh, same culture of Hyderabadi culture and all those, and situations also. And on many aspects, we are trying to collaborate and do certain things already I shared with you. So this is time to listen from you, and I will request Dr. Khorke to Dr. Syed and Dr. Sarda, if they can be taken around quickly, that how we developed 2,000 acre more area brought under seed production, how we tripled our breeder seed production, how we developed 9 CR liter already water facility, and which we want to take to 16 CR, how we developed 2,050 acre at a smart farm, how we brought Marathwada, Maharashtra mechanization center with the help of J Farm, how we brought 50 lakh rupees funding from New Holland to train our farmers, and how we have developed this NAHEP center as one of the best center in the country, and how we are going to accomplish that all job by 31st of December, and how we have brought another big projects from DST to continue these activities, more than 6.5 CR, 5.5 CR rupees we have brought from this, and we are expecting 1 or 2 projects from it. 3 projects we got from DST, and 1 or 2 projects we are expecting. They have been shortlisted under NASF. So lot many things, just to encourage my friends, and how we are bringing in changes in the industry. Only thing is the enormity of the campus and enormity of the problems are so big that whatever we do, that looks small. And that is good thing in life. Don't get satisfied. Keep on working, and bring it to the certain level, and give baton to someone else that keep on working on this area. My dear friends, one thing I want to do, and I want support from my friends here and the student and faculty and all. We want to work, Dr. Syed and Dr. Sarda and Dr. Santosh, all 3 yes. We want to try my best. I don't know, best kabhi puri jaldi se nahi hoti, bahut mehnat se hoti hai. But my wish is that do something in 5 years that should have impact for next 50 years. So that we want to do. We are working on it. Thank you very much.
Thank you, sir. Your words and actions always inspires us to do more and to become more. Thank you, sir. I would like to mention here that in yesterday also, all the participants, they interacted very nicely with both the speakers, that is Dr. Santosh Pitla, sir, during his talk on robotics in agriculture, and also Dr. Jha, sir, his talk was on crop simulation modeling and overseas admission opportunities. He also delivered very detailed and informative talk. Both the speakers were excellent, and definitely the students will take its benefit in future also. Thank you, sir. Yes, sir. Now I would like to introduce in brief Dr. Sharda, sir, our today's speaker. Dr. Sharda, sir, has completed his PhD in 2011 in Biosystems Engineering. Currently, he is working as professor in the Department of Biosystems and Agricultural Engineering at Kansas State University, Manhattan, USA. Sharda sir's research has focused on development, analysis, and experimental validation of control systems for agricultural machinery systems, with special emphasis on the automation, sensor testing, development, mechanometric systems, developing automated test setups for hardware, in the loop simulation, high-speed imaging, image analysis, etc. Another area where Sharda sir's group is taking the lead is in the development of thermal infrared imaging system and image analysis techniques required for spatial and temporal management of the irrigation water. Regarding the academic highlights, Sharda sir authored and co-authored several books, 21 journal papers, 11 extension articles, and more than 32 conference papers. He has also given 24 invited talks, more than 70 extension talks in various forums. Sharda sir has won several awards, including the K-State Innovator, Engineer Member of Year, ASABE Kansas Section, Precision Agricultural Researcher, presented by National Conservation System, and several awards. He has secured grants from the leading multinational industries based in US and India and the federal agencies like NSF and USDA. With this brief biodata, I request respected Dr. Ajay Sharda sir to start his lecture. Please, sir.
Good morning, everyone, and thank you so much for this invitation. Really honored to be here, and especially to meet Dr. Indramani. I don't know what you think about what he just said, but he just said some of the, you know, concentrated like crux of the life lessons. It all takes to believe, right? The day you believe what he's saying, it is right, you're going to start practicing it. And the moment you start practicing it, you're going to see that, you know, they work. And then the final thing come of preaching it, that you will start to train the next generation of, you know, engineers and, you know, people who would like to, you know, work in a similar passion and similar zeal kind of a thing. So thank you again. Really honored to be here to share some of the things what we are doing. I'm Ajay Sharda. I'm a professor in the biological and agricultural engineering. That's okay. Oh, okay, okay. So the other thing I would say is I'm also the director for research for the Institute for Digital Ag and Advanced Analytics. That is a brand new institution which has been established. It's directly under the Office of President at K-State. So we're really excited about for that opportunity. The thing I really want to start is to talk about this opportunity that we have, Institute of Digital Ag and Advanced Analytics. It's an effort, you know, from the institution standpoint, right? We wanted to develop something interdisciplinary. We want to bring people from different colleges. We want to bring people with different expertise, and we want to bring people who are ready to contribute beyond their labs, beyond their own research program, to develop greater faculty into developing their own programs. You know, we want to foster greater industry interaction, you know, collaboration, and we also want to foster lots of cross-institutional, you know, collaborations as well. So this institute has 6 directors. You know, there was a lot of, you know, resistance, and we were cautioned that for an institution there has to be one director. You know, it won't work, it will be difficult, who is going to make a decision and all. But we have been steadfast that we would like to have a shared governance. You know, there has to be a democratic way of, you know, pitching your ideas, and we're gonna move forward as a collective team rather than a single individual. So feel free to go on this website, see what we are doing. The goal of this institution is to work all in the research, teaching, and outreach, which is the 3 missions of the land grant system in the US, and this is how we're gonna do. So this is one of the most pioneer thing we have done. There's a lot of work to be done, but it's just a start from where we are. The other thing I would like to share is my own lab, you know, Farms Lab. This is what we call, you know, fusing automation and robotics for ag machine systems. These are some of the things in terms of focus areas we work on a day-to-day basis. I'm basically a trained engineer, a little bit on control systems, a little bit on sensors, and a lot more on, you know, crop protection liquid application systems. But I was part of the team with my major professor, we were engaged in planting systems and all those things. Um, but coming to K-State, I quickly realized that if I only keep working in crop protection, that I may not have a funding or sponsored research to develop my own program, right? I can continue waiting, for that funding and opportunities to come. So there were some opportunities where people are talking about thermal imaging. So there were some faculty who wanted to work on it, and there was no person who was working. So we ventured into some of the computer vision and imaging things. But now we have these, 5 or 6 verticals. We have a core team who takes care of all the planting systems research. We have a core team who takes care of all the crop protection research and computer vision and so on and so forth. I think in the last 3 to 5 years, our focus, so we are a big part of the innovation teams, both for the John Deere and CNH, 2 of the major machinery manufacturers in the world. Very fortunate that we started working on some developed technologies to understand, its operation, maybe do some validation, verification work. But we have been very blessed that we are now part of their innovation team. That means we are talking about either which are the products which needs to be developed in the next 3 to 5 years, or conceptualizing projects which are the needs for next 10 to 15 years, right? So we are going to continue working in these 2 areas. But as we ventured into these 2 larger verticals from equipment standpoint, one of the biggest needs from industry are 2 things. One is data science, and one is the computer vision aspect of it. So Dr. Pitla might have talked to you about these things. He's the leader in robotics. He's the leader in a lot of computer vision things and automation sphere. We have been trying to add more and more expertise on a computer vision side, right? Everybody wants to see things. Everybody wants to control things based on visual measurements or visual determination of machine operating parameters. So that's the biggest thing. I'll talk a little bit about what we have done, and I've kept my presentation to talk a little bit about what we are doing. That will also give you an idea that what are some of the things which are being done around the U.S. in the machinery area. And then from a data science standpoint, as we are growing our operation, from research standpoint, we collect lots and lots of data, right? We were doing some simple statistical analysis. We were giving some very high-level inferences, but they were just not enough to help the manufacturers to draw any knowledge to improve their products, right? We would like them to, you want to help them to make their products more smart. And so smart is a very loosely used term, right? Everything is smart in these days. When we say we want to make products smart means, so we'll talk about it in the next slide probably. So we wanted to make those things smart so that customer or the user who's using those technologies doesn't have to do a lot of decision making. You guys understand what I'm saying? So there are lots of computers and sensors and all that. I have to physically adjust or program things. So if I make the system smart, then I am helping the user to make decision on his or her behalf to make those things work efficiently. So that's where we were going from that standpoint. And obviously remote sensing is the last wing. None of our projects right now at K-State is there which does not have a remote sensing component, right? We are doing some very hardcore research projects with breeders, genetics people, to help them accelerate the process of shorting out their time frame. And I have few slides to share. But on the contrary, if you want to talk about machinery management, machinery operation, there are a lot of things which we can learn, right? Anybody who has done scouting, you go out, take measurements in the field. Anybody who goes take measurements in the field, right? So you go out in the day, you can take so many measurements in a day. But if you have good remote sensing, approaches, if you know what you are looking at, you can understand the behavior of the entire field. That'll give you an idea. Sometimes you can miss some of the things in a short area, but on a larger scale, you won't be able to miss if you see that information. So these are some of the verticals we have been working on, and we have a team of 25 people, lots of grad students, full-time engineers, technicians, and all that. So feel free to look at it, and if you have any questions, there's a email address on that. You can reach out to us, and we can help you. So I thought that I'll give you some, before I start anything, I'll give you where we are on technology front, right? From a perspective of machinery aspect of it. So I included just a few pictures. These are very large machines. We typically end up using, I don't know, upward of 500, 300, at least 350, 400 horsepower tractors. We can cover lots of area very fast, very quickly. Two things have happened. Machines have grown bigger in size, and we can operate these machines very fast, right? Our planters can run easily up to 8-ish miles, which is, maybe 12, 13 kilometers, right, Santosh? Some in that ballpark. And underneath you can see, a liquid application or crop protection system, which can operate anywhere between 16, 17 mile, 18 mile per hour. So we can cover lots and lots of area. But what has happened, from what we are doing is we are really moving towards, high resolution, feedback and control. That's what we were talking about from a control system and smart technology standpoint. We are trying to embed a lot of intelligence. So giving you an example, we were taking lots of data about anything like planter or sprayer aspect of it. We are trying to harness a lot of that data, understand what data tells us, and some of that data, after the data science component, can become part of the control system on the back end to do things on behalf of the user without even his knowledge or her knowledge, right? Now we have lots of women farmers who drive tractors and combines all the time. So both of those cases in that part. The next thing, which goes in hand, from a intelligence and control aspect, is we want efficacy and we want accuracy. When you go faster, you tend to make more mistakes. Your machine can become unstable. Your response systems and what you want to place. So we work in precision ag, digital ag. We want to place right amount of product, right place, right time, and all that thing, right? So when you go fast, we want to make sure that those things happen, very accurately in terms of what it is. The last thing which we have seen in the last couple of years is the aspect of automation and autonomy. So we have continued to see more and more sensor integration, more computer vision systems, greater control. I don't know, a few years back we have very few things which were part of those technologies. I can't go into more detail, but some of the things I used to believe that it will never happen, right? Now we have sensors and controls for every row of a planter. We have sensors and control for every nozzle on a sprayer, right? So it's just like mind-blowing that people used to say, no, that's too much cost, or there's too much overhead. But that's going on, in terms of what we want. The simple reason is, I was talking to somebody in this morning as well, that 5 to 7 people are managing 50 to 60,000 acres of operation, right? Only 5-6 people. When they're planting, husband and wife are planting 18 hours a day, right? When husband is tired, the wife brings food. While he's eating food in the cab, she's driving. So they don't stop, because they only have a window of 12-15 days to plant, and they have to cover all that acres in that time. So they are very complex working environments, day, night, dust, speed, width. So that is where the automation is going on. The other thing I haven't seen, but I'm pretty sure Dr. Pitla has talked to you, is we have connected systems now, right? we are now driving two bigger planters in a same field, or two combines, or three sprayers. So those things have to be connected to each other, so I can understand what have you done, so that I don't repeat that thing, again, right? So all that data sharing and knowledge of where everybody else is, that has to happen. So that is the next thing which is happening from that aspect of it. Now, when we data is everything. I really want to again put it out that data is probably the most expensive commodity in the US. Manufacturers want to learn how their machines are doing. We want to learn how well they are doing. Farmers want to know how good of a job they have done, right? How good of a input use efficiency is. So how do we take all that data to one place? We still are struggling to take data from a single machine to one thing, like not struggling right now, but trying to make sense and use it as fast as possible. But when it comes to having 2 or 3 machines at the same time, how do we bring all that data in a single portal and start to use that? So that's the biggest thing. But again, the component is that the robotic aspect of it, right? That the So I don't know about here. So anybody can guess what is the average age of a farmer in US? What do you think that might be? Anybody? 35? Okay, we have a number 35. Anybody else? 45. Okay, she's getting closer. Anybody else? 55. Okay. So average age of a US farmer is somewhere around 57, 59, right? So
All.
oh wow.
All. All.
That you cannot have sword in one hand and begging bowl in others. You can't have sword in one hand and begging bowl in other. That is the belief of India, and that's how we have sustained. And we are first or second in a production system of all agriculture or related produce in the world. World is looking towards us, Dr. Sarda. Wherever we are going outside and making presentation, that's why you are very, very important people, because you are related to a profession on the basis of which your Prime Minister says, our Prime Minister says, if need arises, we can feed the world. Understand? And I told them that continue with agriculture, because computer you can't eat. If rest of the world stops supplying you food, then what you will do? So this is the important thing, that average age of Indian, this US farmers is 58 to 60 years of age, number one. Number two, another point is that mechanization, automation, on which Dr. Sarda is lecturing, and automation has been one of the top 20 invention of the world in 20th century. Top 20 invention of the world in 20th century, which has brought peace in the world. Which could, based on that only, 98% people of US could get out of agriculture, and only 2% people are doing agriculture और खुद खा रहे हैं, दुनिया को खिला रहे हैं, ठीक है ना? So that's how important. There was a time when 50-60% people in US also, because shifting from primary to secondary, secondary to tertiary, that is the process. So if somebody says that even today we are 53% of Indian population is directly indirectly engaged in agriculture, and contributing, recent data is only 15% to GDP. It had gone up to 18%, this has again come down to 15%. But these percentages are not important. Important is total production and total growth. And that's how we are going to become multi-trillion economy. And another thing which I observed there when I was in Canada, that what is the average tractor size, which you think in US or Canada? Average tractor size, horsepower wise. Tell? 55? 500. 500. And when I asked that why you are keeping such large tractors, can't you keep 10 tractors of 50 horsepower or 5 tractors of 100 horsepower? Then they said that it is easy to afford tractor but not the driver. Am I correct? And that's why they are thinking of now, shifting from driver-driven tractor to driverless tractor, which is not. So, world has, all different kind of lesson for us to learn. But the good person is one who does the things according to his requirement, his need, and his means. His or her requirement, needs, and means. So that's why we say that we should not copy any country. Only thing, we learn something which we can incorporate in our things. I was in Nigeria in 2018-19, Dr. Sarda, and large number of senior people were there. They gathered in there was an international seminar, and then they said, and I quote, and they may be wrong, what they said I'm telling you, that we did wrong, that we followed US in our agricultural development, having large size tractor, this and that. We did not follow India. We must have followed India, and that's how India is starting from small size tractor for ICER, in 1961 with 880 tractors, starting with 880 tractors in 1961, and now we are producing more than 1 million tractor every year, and we are the largest producer of tractor in the world. So good thing is that in India, I suggest Marathwada and Maharashtra should have its own way of development, and probably UP and Punjab may have a different way of development. Recently, we were doing this National Seed Congress, and then there is nowadays a kind of this kind of everybody is talking one nation, one rule. So in agriculture, I said that you cannot say in seed production system, one nation, one rule will not, because nation is a lot of variations are there. Indian agriculture is diverse and complex. We have to understand. So you may need US technology also, you may need Europe technology also, and a large part of India is still comparable to Africa. So there you have to African, that suitable technology, some part of Japan. So we are mini world. So we need the solutions applicable in the world in different pockets of the country. That's what I wanted to say when world agriculture kaise badal rahi hai. And many countries are facing many different type of problem. But India is still doing fairly well. And thanks to our experts, a large number of our experts are there in US. All these work my friends are, doing and shouldering the responsibility. Thank you very much.
So, thanks, Dr. Indamani. I think that was my cue to say that we have very few people left in the US, like less than 2%. When we are probably in under 1.5% now. So we need to be having larger machines. We need to have larger farms. And the other thing, Dr. Indamani, what is happening is that the farmers who are retiring, right? At some point, I have to retire. And most of the times their kids are gone. They are living in a life in urban, cities and urban setup, and they don't want to come to those rural setups because there are no restaurants, there are no good schools, there are no bars, no good, all those things, no facilities are not there. So who is going to take over? That's the next biggest challenge in the US, is that once I retire, who is going to farm my land, right? So that's the next thing which is happening. So that's driving the entire need for not only large machines, but what Dr. Pitla is doing, the autonomy aspect of, because we won't even have people to be on a single machine. We want now 3 or 4 machines running with the help of only single man, or single person, sitting by the edge of the field. One thing I would like to say, you've seen some of the smaller robotic systems, from Dr. Pitla's, lab and work yesterday. I personally believe that's the way for future, especially in the Southeast Asian countries where we have smaller farms. Inexpensive, smaller robotic systems can be a boon, because every person can operate easily, but he will be able to, or she will be able to do the work in a best possible manner, right? So with this, short background, I want to quickly talk about some of the things what we are doing, and also it will also help you to give some insight on where things are going, right? So from a planting standpoint, one of the biggest thing for a planting system whole life cycle is I would like to place the seeds very accurately in the soil, right? Seeding depth and seed placement is one of the most important component. If you haven't done that, crop protection, crop management, nutrition, just doesn't go anywhere. So that's the most important activity. And once you release the seed from the planting system, it's gone. It's under the soil. I don't know where it is. I don't know, how until it comes out. And when it comes out, I have very little opportunity to do anything because time has gone. You have to plant the seed in a very specific window. Well, you can plant later as well, but you can continue to lose on yields and potential, of that crop. So we really wanted to put something as a system where you can see the seed being released. You can see how well of a trench, seeding trench the planting system has made. You should be able to see what is a, seed spacing between 2 consecutive seeds. We would like to see what kind of a trash, seed, crop residue which is in the trench, which can inhibit or, actually impact the germination or seed to soil contact. So this is a small system which uses a camera, and a laser line scanner and some GPS and all that. But the whole idea is it sees as the seed is being released. It gives you the total count of seed. It gives you, the seed to seed spacing, on the go. And then it helps the farmers to make a lot of informed decisions. So while you're doing it, I thought that I would put this slide to talk about what are the steps. If you want to go into the computer vision side of it, there are components of acquisition, dealing with the image data, dealing with models, detection models or developing the existing models, and then how do you converge that data to use in a machine, right? So if you want to go in a computer vision field, these are all the things you can do, or at least you should be able to do all of these things together, so you know exactly how to build a system, what kind of cameras you should pick up, what should be the how do you set up the area of interest and all those little things. But what this thing has done is that while you are planting, you can see every single seed being detected. It has given us an opportunity to learn about our systems, which we were never able to learn because you just can't see it, right? Once you start seeing it, things change completely. You have never seen some of the things happening in your machines before from that standpoint. But the biggest thing in all of those things is, so Dr. Nirmani talked about the connection with farmers, the connection with community and working to enhance the technology aspect of it. We never take any project in our lab if it doesn't have an outcome for the farmer to either learn about a machine or improve that machine for the manufacturer. If it's just a thing for for the sake of doing something which doesn't have a direct impact, we don't do that. So just want to put an example that if you think about a project which is broader in scale, right, which has implications beyond your own project. So if you see this project itself, it has lots of deliverables from a single project, right? I can see things real time, right? I can make a map of it. I exactly know how many seeds I've planted because every seed is counted and every seed has a GPS location, right? So now you have a map of every single seed being planted. Now if there was seed which was blocked or seed tube which was blocked, you know where were the areas which has no seeds. Now those are the areas which are prone to weed population. So you can plan it differently, right? The second thing from what it gives us is the operator confidence. So when you're sitting on, so Dr. Indramani talked about tractor size, and we are talking about planters. There is no single equipment in the U.S. which is less than $500,000-ish. That's a lot of money. And if you combine tractor and planter, we are talking about at least $1 million. So I've spent $1 million, but do I know that this machine is doing the thing correctly, right? So I always continue to guess that, oh, am I driving too fast, or is the tractor or the planter even working? So having a data like that on somebody's hand gives me a lot of confidence that, hey, I've done the right job, the machine has done the right job, and I'm to the next thing. That's the second component of it. The third, which is the most important component, is that how can we help the manufacturers to make these products even more smarter, right? That's where the word smarter comes back here. Now, in the beginning, I have no knowledge of how well the seed is being placed, right? Whether the seed goes to the sidewall, whether there are lots of misses, do I have doubles, whatever those conditions were. But if I know this information real time, that how good my depth is and how good my spacing is or how bad it is, I can control my machine parameters, right? So I don't want to go into details, but one quick thing which I think you guys will understand is all of these planters work, use some sort of a vacuum to hold seeds and deliver seeds. One of the very simple thing is that if I go faster and faster, I have to pick more seeds in a shorter amount of time, right? So if I bump up my vacuum, I can do a little better job in having the seeds being picked up right. So having this information can be embedded on the back end. Now the operator doesn't have to do anything. As soon as the machine sees that the seeds are not being placed well, it knows what parameters needs to be changed. Does that make sense to you guys? Right? So you can identify the parameters which needs to be changed to make that machine continue to work at that level. So most of those things which we do, we always see that there has to be benefit to the farmer, there has to be a learning from what we are doing, and then what can we do in terms of helping the manufacturer do a better job. Here's another example. We have very large booms, sprayer booms, and there are a lot of things going into the sprayer world. I won't go into that. But our sprayers are 120 foot, 130, 35 foot booms, which are very, very large. And actually, we are going larger than those booms as well. And one of the most important thing, if you want to apply the product correctly, is that you have to maintain the height of the boom from the plant. I was talking to some people who are driving, UAVs with liquid nozzles and all. It's important that you maintain the height from the nozzle tip to the plant canopy. So we don't know how much. We know that these booms move a lot, but we don't know how much, and we don't know how to correct those things, how to make those feedback systems. So this is another example of developing a computer vision system to look at that and how good those data sets are. But again, I thought I'll grab another slide to give you, if you want to do this work, is that when you go into developing a computer vision system, you will learn things which you have never thought you know about that thing. The simple reason is because now you will try to understand every single scenario of that machine which can happen in the field. You know, in a normal situation, you don't care too much about it. But when you have to build a system which is an automated system, you have to make sure that that system works for every single environment. And you have to make sure that it doesn't fail in any single situation. So you will start to understand and explore things which you have never heard before, right? So I think this area is particularly interesting because when you are trying to build, because automated systems are only that good as their intelligence is. If you haven't considered that scenario, it will fail. So you have to make sure that none of those scenarios got missed out when you are developing that thing. So just a little snippet of what is going on here. From a remote sensing standpoint, I'll talk about a little bit, but thermal infrared imaging is what we have been doing for many years. This is for the past 6, 7, 8 years. We picked up thermal infrared imaging at a time when not many people were doing that. We also thought that thermal data gives you an opportunity to learn about plant response before the plant symptoms or visual systems symptoms are shown, right? So you can do things earlier than that. One of the things which we ran into is that when we are using these UAVs back in 2014-15, is that they were not integrated. You know, we need some sort of a sensor or a computing package so we can communicate with cameras, we can trigger cameras, we can geotag images with an RTK, information and all that. So this is one of the things which we have developed in our lab. It's a one-stop shop, right? So this little board you're looking at the bottom right, it gives you an opportunity to tag the RTK GPS data to your camera. It has an option to synchronously trigger any color camera along with the thermal camera with a very accurately known distance. You can actually take an output, of a GPS information and use it as a GPS receiver on your planter sprayers. So you can now use it beyond just UAV. Now this also has 9-axis gyro, so that will give us the yaw, pitch and roll. You can correct images, and this can be used for all the ground robotic vehicles as well, because the application is exactly the same, right? So this single board was instrumental in giving us lots of flexibility to collect data. One thing I would also like to take a little pause here is that we believe in collecting our own robust high fidelity data at all the time, right? We work with large manufacturers, but we rarely use the data which those machines produce. Not saying that that data is not good, but that those sensors are integrated, with the thought that they are going to be integrated on a large scale, right? And they have their own ways of collecting, data in terms of resolution and accuracy aspect of it. So these kind of systems gave us an opportunity to collect data at a very high fidelity, high accuracy, and it is all custom. You can change anything in terms of data acquisition and integrate anywhere, whether they are ground vehicles or remote, aerial vehicles from that standpoint. Any questions up until now? Are people still awake? Good. The other thing I would like to kind of talk about is that whenever we use sensors, right, we just cannot use sensors blindly. Like I cannot just go buy a sensor based on until I don't have a full knowledge of it, I can tell you lots and lots of good sensors just do not work correctly when you use it in a way, just the way you want to use it, right? So for a long time, our focus was not, we were focusing on building systems, sensing systems rather than going into the agronomic aspect of it. I didn't mention that when we was talking about the Institute of Digital Ag Advanced Analytics. We have a computer science guy, we have a statistical guy, machine learning guy, we have a geography guy, and we have a bio and ag engineer, we have an entomology, and we have a core agronomist, right? So I always try to stay in my lane, not because I don't know it or can't do it, but I have a team member who is more stronger than me, more intelligent than me. So we were talking to one of the crop breeders and all, and they were saying that thermal systems just do not work. They use those infrared radiometers. Have you guys seen those infrared radiometers? They're not cameras, but they just grab the entire scene and it gives you one data point, right? Now, for a couple of years, they continue using it. And they always used to say that the data starts to give you some biased information as you progress. So, can you guess what might have gone wrong? Did they pick up a wrong sensor? Did they deploy it wrongly? Right? I don't know. Deployed it wrongly, okay. What else can be there? Anybody? Okay, maybe calibration issue. Very important thing, right? Whenever we use sensor, we make sure that we calibrate those things right. Now in this case, those infrared radiometers were placed in an aluminum shell. The idea was to protect them from heat or sunlight, because the sensors are susceptible to outside temperature. As the sensor heats up during the day, its calibration continues to move away from where it used to be. They never thought about it, they never researched on it, and the sensor was great, but the data was coming wrong. So their trust went away from using that sensor, right? So that's one thing. The other thing was, people, when we talked to those breeders, they just picked up a camera, right? They started flying at a certain altitude. Now you can do that, but it can really limit your ability to extract quality data out of it, right? So in all these images, you can see that this bluish thing here is your right data, right? And if you see data here in this image, you only have single array of good data. So if you extract, and this is all being done manually up till now. You have to go in a remote sensing imaging and you have to draw a little transect and you extract information out of it. So you can get lazy, you can get tired, because there are hundreds of breeding plots and there are hundreds of single rows. And as you start to divert, you're gonna have wrong data, and then you can say, well, the sensor doesn't work. Make sense? So this was another effort to make sure that people understand that picking a sensor, understanding how it works, understanding how to use that sensor so that your data is flexible and more robust is very important. We cannot just blindly pick a sensor and use it by not understanding those things earlier. But if you use those things, we have been using these things for irrigation scheduling. We have been using these for breeding programs, especially working with soybean people, trying to develop some resistant varieties and so on and so forth. The other thing which we have been doing something is around the autonomous systems aspect of it. This is our, I don't know, Gen 2 sprayer system. This is a project funded by National Science Foundation, which is one of the premier funding agency in the US. There are some industry partners, Topcon, they manufacture GPS receivers, TJET, they make nozzles, and you see another name, Microhard. It's a company out of Canada. They make radios, so long distance communication. So, so this the goal of this system is to go in a sorghum crop and real time look at the leaves, detect the geolocation of aphids, and spray them with the chemical, collect all data, and put all that data out on the edge for people to see on any kind of a user interface, whether they are tablets or cell phones. A lot of things have gone on in terms of building, image data sets and looking all that. This year it has been specifically, we have four graduate students in this project, understanding the mounting and how good can I see every corner. There's one camera enough, to do all that. Are we successful in, at least locating 70% of colonies or so on and so forth. So it's been amazing, amazing journey. Everything, I don't know, Santosh is a couple of years ahead, many years ahead, but we were able to put everything, deploy everything on a single machine and do from start to end operation, on that part, no gaps. So here is a small kind of a video of what we were looking at. Initially we have problems, navigating this kind of a machine. So you will see that we have purposefully taken it into a field with a contour. These are not straight rows, this is a contour row. So it's going pretty decently. The other thing when you will start working in autonomous systems, you will know that maintaining speed in a crop is not easy, right? You have to be careful about following the paths. You have to be careful about the crop should not get damaged. So if you are successful in keeping your autonomous robot in a path, and if you can maintain even 2 miles, this is just my thing, I don't know, Santo, what Dr. Pitla thinks about it, but if we can start with somewhere on 2 miles, that's a really good speed, and this is really good. We were able to get up to 2.5, 3 miles as well, and be good with that. So, so our goal again in this, and I can tell you another thing, we were never funded for what we have done in this project. Our funding was only to put out bits and pieces of these, systems in there. There was no funding for communication. There was no funding to put everything together to make it out. But our goal was that if we want to go back to the funding agency, we should be able to tell them that whatever money you gave us, we were able to capitalize on it. So I only have funding for one graduate student. We do other projects. We save money. We go to other agencies and we continue to hire, because if I would have given this project to single graduate student, we would not be here, right? So one graduate student's job is to only build a liquid application system. One graduate student job is to build only the algorithm for navigation and control, right? And he's doing higher level or lower level multi-agent, operation within a single field. One guy's job is to program everything under a ROS package, right? So he's integrating all the systems. One guy is building all the communication system. So if you really want to do that, you have to put a team together. You have to put a team of people who can work synchronously. I don't know, we heard something about it. It's a similar story everywhere. People just don't work with each other. They fight. There are difference of opinions. Somebody wants to take this route, somebody wants to take this route. Somebody thinks that this is the best sensor to pick. Very fortunate that these 3 or 4 people are, so synced with each other. Yeah, it's a rare thing, but that's the reason we are here, from this project standpoint. The other thing on this thing is that when you have a system like that, now you have to start putting some robust information around it. What can you share with the farmer, right? Farmer is going to start asking question, do I have to go in every single row? Or how can I increase my efficiency aspect of it? So one of the things which we wanted to finish before we go to the next stages is that can we just go alternate rows and be good with that? That means if I spray on this side, both sides of the plant is able to get enough product, right? So we've done some projects. Again, think about it. Entomologists are our key goal. We sprayed some of the chemical. We got to know that if you spray on one side of the plant, that is more than enough to get, perfect control. Because with this system, so how many people are working in something relating with sprayers? Anybody working with sprayers? Yes? Right? Okay. Couple of them. So when you work with sprayer, there are a couple of things which you really want to achieve, right? You really want to see that, can I get only decent winds? You don't want to spray in winds. In Kansas, winds never die. They are always 15, 20 miles per hour, right? You also want to spray that the temperature is not too high, right? You also want to maintain speed, but not too much speed so that it doesn't volatilize the material or do drift, right? So when you use these kind of systems which are under the canopy or in the canopy, I have a good microclimate, I have much less winds, I can now put the product on number of locations. On a top up spray, I may be able to cover maybe the top portions of the top canopy. With this thing, you are putting product at numerous locations within the plant. So now we can decrease the dosage and the application rate significantly. Not to say that we will only spray in those areas which need spraying, because we're not going to spray any plant which doesn't have aphid, right? I cannot believe 100% of the plants have aphid, right? My guess is maybe 20% or 30%. I'm just guessing. So we were able to see that enough coverage is done from that standpoint. The last thing I will talk about the robotic system as well, but from a data. We are starting some of the data component here is that as you use multiple agents in a field, this is just my AJ Sharda's opinion, is that you have to have a system for real-time data communication and data assimilation. Because if you're sitting at a home office or at the edge and you have 5 robots or 10 robots going on, I have to know where each one of them is. I have to know the needs of each robot. Does it need, say for example, you're talking about sprayers, does it need water? Does it need battery change? Is it even working, right? Is it stuck somewhere, right? Does it have any fault in the system? So I need to know all those things, because it's very important for me. They should not venture out on the road or somebody else field, or should not hurt anyone. And I cannot do this thing post operation. It has to be real time, because the person is not there, right? So human in the chain has to be, and I firmly believe that for next decade at least, or maybe more, human will always be in the chain. Full autonomy is ways away, right? A human will continue to be a watch, dog to kind of see where. So we have a fully operational system where you can put data up to 1 megabits per second. That's a lot of data in terms of what we are generating here. We haven't gone, but you can go even, video and image data as well. But what these things are doing, they are collecting data. They are, communicating with the central hub. It is putting all the data on a cloud source, and then from cloud source it is coming to the tablet aspect of it. We have been trying to put a proposal. We're going to put a proposal again. We want to develop a knowledge graph. That's another up and coming research area in the US. That means you bring heterogeneous data sets, right? Sometimes you collect data once a day. Sometimes you collect data once a second. Sometimes you collect data once every few months. I don't know. Sometimes you collect data once 1,000 times a second. So how do you bring all those data sets in a common platform from multiple agents and be able to do, whether it is neurosymbolic. So there are 2 types of, AI, which is, so one of our core team, our director of research, he's an AI guy. So how do we do neurosymbolic AI or geospatial AI on that part, right? So to to develop that part, this is one of the core things. You know, we are trying to do. We are trying to put some proposals, and Dr. Pitla can vouch that it's not easy to get money there, right? You feel that the proposal is really good, but people doesn't. So this is where it ends, and I think it has to be a part, because without your ability to look at data, right? So I don't know how much you really feel it. I need to know every robot's need, right? Otherwise you're losing efficiency, you're losing time and work aspect of it. Finally, I'm going to talk a few things about data science. Like I said, so I have a 20 people team. I have 5 to 6 agricultural engineers. I have 6, 7 mechanical engineers, a couple of electrical, a couple of computer science. We have a couple of communication guys. We have core data science people, 2 or 3 people who are only doing data science work. And we have 2 people who are core agronomists, because we were trying to work with some people. When it comes to your project and project needs during the season, it just doesn't work, right? So we thought we're going to hire some core agronomists into our team to help our projects. So the data science people, I cannot tell you how good of a decision we have made to put some people who are data science people on the team. So this is an example of a breeding plot, right? You can see these individual rows of a 4-row planter, who has planted. They go out, they plant anywhere between 1,000 to 2,000 different varieties or trials they want to put in, right? So what the same example, what they are still doing is that they collect a remote sensing data, and then they draw fish nets, and then they go like plot by plot and lane by lane to draw transects and extract information from that part of it. It takes them 3 weeks to finish one data set, right? And also, what you were talking about, you have to be accurate, right? Otherwise people get hallucinated, tired, fatigued. They go back, take some rest and all that part. So one of the needs was, can we automate the whole process of data analysis, right? So one of my grad student, she has finished one of the biggest leg of this work. So when these 4-row, 2-row, 6-row planters work, we just need one data set, and that data is the GPS data in terms of starting and finishing that plot. You guys understand what I said? I need a GPS information of where that plot started and where that plot ended. Only 2 data points is more than enough. So based on that, this complete algorithm, draws lines, extrapolates other rows. You just need to tell us where the GPS receiver was mounted, how many rows are there, what are the row spacing it is there, and it is completely flexible. You say I only do 2 rows, fine. If you say I do 6 rows, that's fine. You say I do 24 rows, that is fine as well, right? So once you do that, the entire process is completely automated. It draws lines, polygons, and then it starts to isolate everything based on what you say. You can say I want to isolate every row, or you can say I want to isolate the entire plot, right? So it grabs all that data with a single click of a button and brings all that data in a single sheet, where all 32 different vegetative indices are there, and all crop response parameters, wilting index and yield and plant height. You can do whatever you want from that part. And what it has at the end is a statistics and machine learning backbone. You can check off what kind of plots and analysis you need, and when you will click, not only it will extract all the data, it will give you the right analysis in the form of tables and plots the way you have decided, right? So it has really reduced this work from 3 weeks to 30 minutes is what it takes. right? That's a huge improvement. Now I can use multiple data sets, on a daily basis. I can bring numerous data, I can do daily analysis from that standpoint. And I think most important thing is that people are relieved because they were sitting on the computer trying to extract data, hour by hour, day by day, which was just completely laborious. It was taking away the whole essence of what they wanted to do. So that's that's the crux of what I have to say. These are some of the things we want to do going into future. But if you want to see or say what our focus is, we want to continue working more and more on non-destructive sensing technologies, right? How can we build systems which can grab data, right? There are some other very, very exciting projects where we are trying to build computer vision systems from end to end. I gave you some examples of fractured, systems because I want to grab a very specific data. But now we are trying to build a system which is from end to end, complete computer vision, which will give you a sense of, how was the soil condition, how was the planting condition, how good of a job the machine did, what was the response of the plant, everything. You don't have to go back, right, to do anything like that. Intelligent systems for ag input application, so like I told you, we lots of innovation projects in the pipeline. Maybe continue watching the publications, but there are lots and lots of products which I'm really excited about. One of the product which is being under development by one of the manufacturers. So I really hope that it shows up as a product. It will be one of a kind. We don't have that solution or system with any manufacturer. So that intelligence is going to continue to go. Predictive models and decision support, that's what you saw, all the AI aspect of it. Not only the AI from computer vision, but AI from a data, harnessing the knowledge which is in the data set. That's our goal. From the people, so if I start collecting automated data, do you think I can trust that data all the time? Why? So I see lots of heads nodding that no, I won't trust. Why won't you trust? You build that system, you fixed all the things, but why won't you trust it? Okay, maybe you have to validate, right? What else? Well, the systems don't work good all the time too, right? Systems can fail. And one of my other personal thing is I believe that the next generation of work is going to be some sort of AI intelligence on the data we are collecting, right? So as the data is coming in, I have to see how the trends look like. If I see certain data being collected in a very odd fashion than by other sensors, I have to believe that something has gone wrong with this particular sensor or with this particular subset of data which is coming in. So it's very important for us because when you collect data with system, you want all the luxury. You would like to collect more data, you want to collect more, you want to put more systems or sensors. It will be a sea of data. How will you make sure that the data you have collected is correct? I can tell you, if I give you even one single sheet of data from one field, by the time it is evening, you're going to say, AJ, I'm sick and tired, man. You go figure it out. It just doesn't make any sense, right? So developing those AI, solutions around, understanding that I have a, formalizing, formal validation of data quality is going to be a very big thing. That's what I was talking a little bit about knowledge graph as well. And then obviously the logistics of autonomous platform operation and how those things work. I don't know, I'm pretty sure, Dr. Patla talked about it. It's easy to say that I will have 20 machines. It's easy to say I will have 10 machines. Well, it is difficult to even get ready one machine and get to the field, right? Now you're talking about 20 machines. Okay, who's going to carry there? Who's going to unload? Who's going who's going to take care of them, right? How do you make sure that those things continue to work all the time, right? So all that logistics, that'll be a completely different area of work. Means people can just make a lifetime careers out of it to develop logistics, around the robotic system. So that's all I have to say. Here is my email address if you want to know it. In purple is my Twitter handle. I don't tweet too much, but once in a while. But then underneath is our Farms Lab link. Do visit our website. We are completely renovating our website, and the bottleneck is me. I'm traveling, and few things I have to fix to give it to my team, but I'm hoping that by mid-January or end of January we'll have a completely new website. It'll link all our team members to topics, to their publications, to team members, so you can surf who are the team members, what kind of publications they have made, what are their interests in terms of work. So that'll be helpful. The other thing which I forgot to mention also is that most of our projects, so I just finished 10 years working at K-State. Almost all of our projects which are beyond innovation, we work with farmers, right? From the get-go, our thought process was that there is no fun or there is no value in bringing data or information to the farmer which is not representative of their own farm, right? So if you are farming on a farms of 100, 200, 500 acres, if you are farming rectangular fields and irregular fields, if you are farming flat fields with all sorts of topography, if I cannot bring all those data sets, then I'm losing some customers in the audience who are going to say, I don't believe him, because he doesn't consider that part. My field looks like that, right? So all of our projects are in collaboration with farmers. We have 3 major farmers in our region, we try to stay close, but we stay somewhere around 60-mile radius of our campus. Think about it. If we plant, we have to scout a field. Well, we first have to find a field, scout a field. We have to do all the surveying, get soil samples. Then we have to plant, get all the equipment there, seed, fertilizer. It takes a lot of preparation to put up a experiment. Then we go twice a day to capture emergence, and then we do depth and yield. So it's a whole life, it's a whole year process. We are to a point now that we only have 1 month break, which is January. We start planning in February. We meet with our farmers, and we decide, we share our projects. And that's another story. When we started, we were getting the worst fields they have, all stones and weeds, because they don't trust us, right? We have come to a point where farmers want us to plant as much land as we can for them, because we have the latest systems. We take care of the fields. We do things better than they can do for themselves, right? So all that thing has been very helpful, not only to bring the practical perspective, but we continue to talk to farmers. I think the best thing in all this ecosystem is that every stage while we are doing things, and the farmer is sitting there, farmer's dad is sitting there, farmer's uncle is sitting there, we are constantly talking, right? We are evolving our projects as well, if need be. We are not fixed on what we have decided, right? So if we see or if we listen something which is going to really impact, or which is going to make our study more robust, we evolve on the go, right? So that helps us to stay grounded and do things which they want us to do, not what I want to do, right? It should have a value to them part. So farmers are the big component of it. And the other thing is we continue to involve our manufacturers in that too. We never publish anything before talking about the methods we have used, not compromising on the data and what the data is telling me, but the method. I want to make sure that if Dr. Pitla has given me a robot, I've used that robot in a most optimal fashion, right? I haven't skewed any of those things. But after that, whatever the data says is we're going to learn and we're going to go from there, right? So these are some of the guiding principles. All these farmers have, each farmer operates somewhere between 40 to 60,000 acres. So if I combine all my 4 farmers, they farm roughly 200,000 acres of farmland. So that's a lot of experience, right? 200,000 acres is a lot of land. So, and they have multiple generations of. So, really blessed from where we are, where our program is, and we hope that we can continue to grow, both from our lab perspective and also from the Institute for Digital Ag and Advanced Analytics. So, thank you for listening to me, and I'll be happy to answer any questions.
Thank you. Thank you, Dr. Ajay Sharda sir, for being with us. When I visited Kansas State University, I saw his lab. It was a big mess, and then all students from India, they are supposed to run through the various types of electronics, mechatronics system, and that's an amazing experience. When I talked to his students in his absentia, because he was busy in the meeting, and I just went there with the students to see how they are doing their all work. I saw that the students are experiencing to develop a smart agriculture machineries, and these are smart agriculture machineries from Indian context point of view. If you see the small farmers, they have a per capita, per head as a land holding. Their needs are just like to cope up with the labor scare problem, labor heavy charges problem, and to make up their in time all operations. The all operations, when he feels that there is a speedily operations required, sometimes timely operations required, sometimes as he has mentioned in the beginning, every seed has to be placed at particular. So everything that goes in the precision agriculture, these all machineries what they are developing, and in contrast to that, it's a glorious day for us now to combine to such a good personality, excellent personality from India who are working in USA. Dr. Santosh Pitla and Dr. Ajay Sharda, they are jointly available for us to have such interaction. So I am really, making this kind of open dialogue system for the students who can read your papers as well, and also learn of those things which you can explore your future opportunities in that direction. Making up, the procedure complete is not sufficient. You have to have some skills, like developing program, writing Python programming, making deep learning models, then using different codes, electronics connectivities, GPS routing system based all operational activities. Those all things are primarily you should know, so that you can go there and work on the big battleground. So there are huge, they have a very big farms. I visited your farms also, and it's likely to say, I request Dr. Sharda sir to open up the kinds of opportunity with his email ID, and then you just go for striking up your only skills which will be matching to his announcements. Whenever there is notification from Kansas State, you should immediately grab that opportunity. So I really thanks. If anybody is having any question, please go ahead, like yesterday.
Thank you, sir. Any questions from the participants? Ubara, stand up, stand up.
How will you find data is accurate or not?
her question is, how do you find that data is correct or not, right? Every time we can take example of the planting system research we are doing, right? Um, we have a history of the type of sensors we used, the manufacturers who are building those sensors, the kind of resolution we need, the frequency of those systems. We have done extensive smaller projects to make sure that those systems are robust, right? First of all, we make sure that we buy good sensors. You can buy an accelerometer for $15. We buy a sensor for $500, $600. I'm not giving a price comparison, but good sensors come with lots of good things, right? Easy integration, lesser noise, repeatability, longevity aspect of it, robust data for a long time. So you are paying money for good quality data as well. Most of the time, not most, obviously 100% of the time, our sensors come with calibration sheets as well, right? From pressure to accelerometer, you name it, right? So, and it is not odd. We bought a torque sensor from a company in Germany, and it wasn't working well, and we went to Dr. Pitla's place and talk about it. They validated that torque sensor in their tractor test lab. We were not fortunate enough to have that, but we have a little dynamometer. We somehow, somebody completely reversed that calibration curve, right? So, first of all, you're gonna make sure that you're looking at a good company, who backs up with the quality sensors, gives you some calibration sheets, and after that as well, you're gonna make sure that you do some parallel data capture, right? All right, here is my example to that. So we were using load cells. People don't understand about load cells. They are bending type, so they are basically giving you the change in resistance and the output in terms of what you're measuring, right? So so when that load cells are mounted on a planter, when there is no load, it comes back to its own tare value, right? What is its value at no load? So for first couple of days of work, we segregate all the data which that sensor is putting out during no load and compare that to the starting point on day one. That's your biggest validation that after thousands, millions of loading and unloading cycles, that your sensor is still at the same place where it was on day one, right? Some of the other sensors, you have to believe it, right? If you are buying such a high quality sensor, if you have a calibration sheet with you, and if you have done some basic checks on the machine, then it's going to be right, right? The other thing is, we always believe that when we are collecting data, that I have to have a monitor or a screen in the cab. Whether we are doing sprayer, whether you are planting work, we typically mount a little screen. It has a connection from a data ACK, so it is giving you live feed, right? So you can snap a wire, you can snap a sensor, something can bang on a rock or a soil or a terrain and get damaged. So we have made our data acquisition system so robust that if something goes wrong, the operator is looking in the front trying to drive, but we have some indicators which is going to flash for him saying, hey, I am missing one data on the channel number X, whatever, right? So that guy has been trained and told that the moment you see anything, we need to stop, because the importance is not to finish work, the importance is to have quality data collected, right? So you will learn when you will collect data, when you will have incomplete data, when you have poor data which will makes no sense, when you will be unable to publish, then you will learn what can be done to make sure that your data is robust, right? So did I answer your question?
Yes, sir. Thank you. Can we mechanize small and marginal farm in low cost or average cost? Or which component use in small and marginal farmer that beneficial for small and large marginal farm?
So is the question is that can we make these systems for small and marginal farmers? Is that the question? Okay. Difficult one, right? Very difficult one because everything comes at a cost. If I want to make even good mechanical systems, the cost has to be high, right? I'm not very much connected with the things, but when I was there, a seed drill cost like $1,000, right? I'm talking about putting one sensor or maybe two sensors which are worth $1,000. So if we want to make, I think, if you ask me, I think the biggest contribution which institutions can make or start to help is to get better and better at using these, modeling softwares. We are still, lots of manufacturers are still doing things with the trial and error thing. Numerous Indian machinery manufacturers do not have a trained engineer on site who can draw, who have a, kind of a modeled machine components. That's why these things are even not standardized, right? Every manufacturer wants to build or use nuts and bolts of different types and shapes and places that they don't even have a compatibility with each one of them. So I think things have started to improve somewhere so I belong to Ludhiana and in Punjab there are lots and lots of machinery manufacturers. So they have at least started to do that part. So I think if universities, wherever these things are going on, if students are, I got my training on a drafting board, right? We have these drafters which we used to draw everything from isometric to all those, we don't need, this doesn't work. So we have to completely move away from that and use some standardized, software, whether it is Creo or SolidWorks and all that. I'm 100% sure if we do that, we will start to connect with manufacturers because we will be able to help them, right? So there is no simple answer for that. I'm sorry about it, because what we can do is we can make inexpensive machines and we can work with farmers to make sure that they use it efficiently, right? Because they are not crunched on time. They have a smaller land holdings. They can pay a lot of attention in terms of how they're using it. So we have to believe and work with human skill along with the the quality or the capability of the machine to achieve that. Yes. So Dr. Bitla is mentioning start mechanization with high value crops, right? So that's a great point. Those crops can yield you a lot of money, right? In that you have an opportunity to invest on technology, right? I don't know. I think all spices and everything, they have such a high value in international market. Like a bottle of turmeric or what the red saffron. Yes, a little bottle of saffron with probably 100 strands costs like $20, right? And you go to Jaipur or other places, they are so inexpensive.
So I would say a lot of times we really think about the cost of technology, but the important thing to think about is the profitability. So if the cost of machine is 1 lakh per acre, but if my crop is making 5 lakhs per acre, all of a sudden your machinery cost is not that expensive. Okay? So I think we should start thinking about profitability more than just the cost, in my view. Yeah.
Excellent point. Excellent point, yes. I don't know how many people are still, I can talk about, Punjab, it's not a very good situation. People have taken so much debt. I don't even know that my land doesn't belong to me anymore, right? So we used to talk about not buying a tractor if you own a 2 acre, 3 acre, because the cost of maintaining a tractor is going to be more than the total land holding you have. You will never be able to maintain it, right? So I think yes, very, very important point. You have to make sense of how much money you are making out of the business. It's a business. It's not a hobby, you know, because you don't have unlimited resources or money to do that. More questions?
Anyone?
I just want to know one thing, that are you also developing like custom ECUs or circuit board for the requirement, or just the control algorithm or software part of it?
So most of the time so I don't think any faculty or schools are building larger machines from grounds up. Am I fair to say? They are very large projects. They have, the biggest thing in that is the IP component of it and all the access and control on the, um, um, the, the proprietary information on that part. We have, so something what you have seen, that's, you know, that little board, it's not an ICU, but we are building some of those things for our robotic system, which are smaller things. But no, we are not building full-scale ICUs for planters or full-scale ICUs for sprayers. We are actually trying to make the control systems more optimal, right? By understanding how the machine operates or work. So our contribution has been more on control system optimization rather than building ECUs.
Yeah, I want to make a small comment about profitability, what you mentioned, and about some of your question on for small farmers, how to do it. I have some experience I want to share with you regarding that. In India, we have about 85% of farmers are small or marginal, and about 40 to 50% people are involved in agriculture, whereas in the US only 2%. Okay. Now, another one is about robots, whether small robots are available. Yes, two of them are working. Dr. Ajit Srivastava on electric tractors from Michigan, and he's using Indian tractors also. It was actually his talk is available in YouTube. I will tell you where it is. In Aurangabad, he participated in the AAA conference. Another one is Ajit Chaudhary from Urbana-Champaign. He's got a company called EarthSense. He has brought a small robot. Now, I just want to add a single line. So they're online now. They are available. India, people are working. We have automated the cereals. For example, Punjab, Haryana, when you go, for example, the wheat harvesting or seeding or whatever, the wheat we have done. Also for rice. But we have not bothered about other crops. The high cost, for example, he talked about certain crops. They are not harvested like this, okay? Like they are grown in different areas. So when you talk about what it was saffron, that you have to go to, mainly it's coming from the north, complete north part, Kashmir or somewhere else. And other ones, ginger and all, their techniques are evolving. But still the big challenge we have is the income. Average Maharashtra farmer's income is about 3,500 rupees per acre per month. Okay, this is the way you can calculate. 2,500 could be, okay, it's from 2,500, sometimes even 1,500, depending on the states, because I have traveled extensively in Maharashtra states, so I know it's average around 3,500 rupees only he gets per acre per month. So imagine, now I always tell this and some of my friends don't like it, a professor gets around 2.5 lakhs means somewhere about 80 acres the farmer must have, and that is the amount of money we are getting. And that's the amount of a government servant gets, a teacher gets. So there's a biggest problem of the farmers, they don't have income. How to improve the income is to reduce their inputs. So that again comes to robots, how to reduce the input cost. We'll come back, I will have, in my session I will talk about this, but I say the automation for the smaller in marginal farms already on pipeline. People are working, and we require the experts like them with the experience with the machines. For example, some sensors cost $500, but we have some institutes which are developing it small, very less cost also. And trade-off of accuracy is what we are looking for. We don't want, see, 80-20 rule we always use in life. 80% of work to be done first, 20% we don't care. So accuracy also we look at, if I improve the income from 3,500, if I include 5,000, I'll be happy first, instead of going for 10, 20,000. So I think it's possibility exists. Thank you.
That's a very great point about, you know, if you only look for this kind of a thing, the cost of sensor can be like maybe just a fraction of the cost. So yeah, no, great input. Any more questions?
Okay. Thank you. Anyone?
Good afternoon, sir. Thank you for this wonderful session. My doubt is regarding, sir, India is diversification is not only in culture but also in the climatic conditions also, sir. So these are the tools, whatever you are showing that that will be applicable in every climatic condition, because in the sometime drones are there. They should not be able to take the flight in the cloudy conditions, or they are having the most of the restrictions. So we are not able to cover the whole field. Where are they are detecting the obstacles. They are not go to cover this land. So it is not possible to cover the real-time data in the all positions of the field. So that was the one my question. And another question is, what are the another softwares you are using for the data analysis? You are only showing the equipments, but I want to know what are the softwares that are you are using to whatever you are collecting data. How should it will be analyzed through, and which are the softwares are beneficial? Therefore, thank you, sir.
So I think the first question is you're asking about all the climate conditions which are limiting our ability to collect data on a spatial.
Because, sir, in India having 20 agroecological zones, they are having the different climatic conditions. So where it is applicable more and where it less in the climatic conditions.
So it comes back to again understanding our sensors' ability to collect data, right? So when I was showing you that slide about camera selection, so a lot of breeding people, they run parallel breeding experiments in different agroclimatic zones as well, right? There are similar breeding, lines which are being tried in Texas and in Kansas and in South Dakota, North Dakota and all that, right? So if you want to collect remote sensing data, if you're not able to compare that data, then it is of no use having multi-site locational trials. So it all comes down to standardizing your methods to collect data so that those sensors are collecting data in exact same fashion from different sites, right? So it's a story of back in 2015-16, we were using these FLIR, thermal cameras, and we did so many, so there was no publication available. The only information which was available was on the website, which was minimal. Actually, it was negligible, right? So for people who want to use thermal cameras, there was absolutely no knowledge. So we end up doing so many small projects. We got to understand that the temperature in the medium between the sensor and the target, and the humidity in that impacts the response, what the sensor is going to capture, right? Because it's going to attenuate the signal, or it's going to, either or the other way, right? So the vice president for FLIR was visited K-State, and he said he just have 5 minutes to visit the department. He ended up spending 2 hours because it seems like at that time they were doing exact same small experiments we were doing. So now if you buy FLIR cameras, there is an option of inputting whether the outside temperature is low, medium or high. Or there's a component of humidity aspect of it, because it has a huge impact on the quality of data you collect. So when you collect data, you just have to understand what are the things which are impacting, like external factors, whether it is the sensor itself or environmental factors, and then you can collect standardized data, across the board, right? What was the second question?
About the data
Software,
analysis
yes.
softwares.
So, yeah, softwares. So we use lots and lots of softwares from a data acquisition standpoint. We have relied heavily on LabVIEW, right? And from hardware standpoint, we are using C-RIOs, which are the top of the line from industrial scale data acquisition. But you can also grab MyRIO, which is very, very fraction of a cost of a C-RIO system, right? So if you go to their website, there are MyRIOs, there are single board RIOs, and then there are C-RIOs. So I would strongly recommend, if you guys want to buy some MyRIOs, they are small, box type thing. They have tens of input-output channels and all. And then LabVIEW is probably the entire data acquisition line, right? We are slowly switching to ROS and Python because if we want to deploy systems on the machines, right? So what you see on a sprayer or some of the planter as well, everything is packaged in a NVIDIA Jetson or NVIDIA Orin or of that nature. And since it has to go at some point to a robotic system, we are trying to use ROS or Python, right, wherever it belongs to that part. So that's our data acquisition. It is common across all. We use every kind of a pressure to speed, GPS, to frequency, to angle, position, inclinometers, you name it, everything, right? So everything is on that part. There is no other software we are using beyond that point. From a data analysis standpoint, we are relying very, very strongly on, so where you have to develop automated data pipelines, we are going towards Python. Whether you are trying to draw inferences, we are integrating Python, R, and GIS all together, right? So the product you saw where there's an automated pipeline to extract spatial data, that lady has developed, various apps and different modules which are simultaneously interacting, with the GIS, having Python backbone or R backbone and all that. So these are our very heavily used software for statistical aspect of it.
Thank you, sir.
Thank you, sir. Dr. Sharda, sir, thank you very much.
Thank you.
Sir has delivered a very nice lecture on the digital solutions in equipments enabling food security and sustainability, with focus on the remote sensing in precision irrigation, monitoring seed placement. Again, he also talked on the sensor selection for good data collection, and also given information about their own research work. So once again, thank you very much from all the participants and the organizing committee. Now our next speaker, Dr. Saeed Ismail sir, we are fortunate enough to listen him in both the sessions, this session as well as in the afternoon session. In brief, I want to introduce sir. He is an agricultural engineering and management professional working in embedded electronics related to agriculture, automobile, automation, process control industry for last 40 years, and holds his PhD in the engineering as academic qualification. Currently, he is on the position of Director, SIFA Sanpra Systems Private Limited, Mumbai, and also consultant for NABARD Consultancy Services at Mumbai. Sir is having skills in the farm machinery, including these irrigation technologies, spraying and weeding systems, precision farming, hydroponics and aeroponics, along with integrated farming and farm management. He is also skilled in these operating systems as well as data management expert systems, AI machine learning and big data. Definitely from his current position, he is having managerial skill as a result-oriented team leader, also planning and cost management, human resource management, and an excellent trainer. Sir has his publication in the reputed journals. Along with that, he has been having several special recognitions as well as awards. Among them, few I will mention here. Apollo Farm Power Awards in 2020, Special Recognition Award for exemplary accomplishment and immense contribution in the agricultural mechanization, also awarded with the ISAE Fellow Award in 2020. With this brief introduction, I would like to request Dr. Saeed Ismail sir to please start. Please, sir.
Thank you for the opportunity. I am a basic and agriculture engineer. As you told already, I'll make it simpler, and I have automation, products and supplies, so I have a good idea about the systems available. Now, last 7 years, I've been called back by my friends to agriculture domain. Now we are, India is growing into agriculture domain. So I travel a lot in Maharashtra also, under the MNE of Pokhara, so I know the present condition. Let me have this session differently. I'm going to handle it differently. Because this also follows the earlier speakers, what they told. Like, if you recall the previous speaker, he told, we don't touch any project unless it's the need of farmers. Either farmer wants to learn or they get some benefit. That's what US, he told, the professors do. So we will see our farmers in India, and let us talk about our agriculture, our farming, how technology can help. What is all you feel, how you feel, and what I feel, how I can help you out. Or where you can find, we can both find a help if something we have questions to ask for. So this is going to be the total content. So for which I would like to know who all of you, okay? This session will be till 1:30, we'll have lunch. Then we'll start again around 2:30. And will for another maybe 2 hours, depending on your question and answers. I have a lot of presentation to share with you later on, once you know what your interest is. For example, in sensors you have, or we'll also talk about technologies, what you call deep diving. He talked about artificial intelligence. Frankly speaking, many of us use these words just like that, accepting experts. We don't understand. We don't understand. The truth is we don't understand. I'm an agronomist. What the hell you come and talk to me? Hey, okay. I don't know. People don't have common sense. How the artificial intelligence, okay? So these are all the questions comes to us as a normal human being. Let us be normal person. Let us be like children. I was taught long back by somebody, when I was studying, they told me, if you don't know something, be bold and say, I don't know. Because then only somebody else who knows can tell you. But we have been trained, at least in the last 2 generations, I see people, mothers tell their children, don't tell the teacher that you don't know. Or the classmates tell this another student, don't tell you don't know. Just to try to somewhere around. So this has been a little bit of challenge for all of us. So let us leave all this aside, because this is not going to be a session. We will talk about all the topics, okay? Like every topic, you have questions you can ask, because Basically, I'm an agriculture guy and an engineer also. Plus, I worked in industrial electronics and computer science. I know almost all the languages. I started in 1978 by learning PL1. I don't know your PL1 language, and APL, there's a mainframe computers language, then COBOL, Pascal, whatever you call, Python. We can talk about all these things. I'll explain you how to understand what is Python, why people are after Python, what is C# and C++. So you will have basic idea. Okay, it is basic important for you to understand what is what, where it is available. You can't be expert of every line. Previous speaker also told one thing very important. The previous speaker also told something very important. That he has a team of people. You remember, he told he has some electronic people, and he has some people worked on expert systems, AI and everything. He has got agronomist, he's got a pathologist, he told. I mean, that is a teamwork. A farmer, where he belongs, a soil science guy, or agronomist, or an engineer? Who is a farmer? Why the hell we expect farmer to know everything, and we educated, we separate ourselves, I only specialize on this. This is probably what we have to learn. And you know, it looks from the US and everywhere else, oh, this guy is talking very nice. Don't think he's alone. They work in team. In Europe and US, they work in team. They have no fight between disciplines. I always recommended this agriculture university must have electronic professors, equivalent to agronomy professor. Okay? Why not? A mechanical engineer, a chemical engineer must be there. Why we should separate agriculture engineering department means only farm machinery professors must be there. That is idiotic, no? When you want to go to kitchen also, food you want to eat, somebody want to eat Chinese, somebody want to eat Punjabis, you want all the cook, correct? But practically, I think we should change. What I think is, nothing wrong, we have been doing that, agreed, but think about it again. Let us see, think about it, what we are doing till now, correct, where we can change, because change is something permanent, that all we know. So let us start with that note. We will start slowly because we have very less time now. I would like to understand you. How will you start is, I will pass the mic, tell your name, and tell, for example, your main work, what you're doing, agronomy, even though I don't want to divide, but tell me, which is the area of interest, let me put that way. Agronomy, pathology, or engineering means, agriculture engineering enough, no need for soil science, you want to say something. And any project you're doing, which are important, where technology requires, according to the title, we have climate smart agriculture. Okay, climate smart means, you know, मौसम बदल रहा है, बहुत change हो रहा है, so correct? That is a climate का anything you are doing, or you are working on any new technology. New technology means even genes, okay? Seeds, also new technology. ऐसा नहीं, you think only electronics comes technology. It's not a question, it's a technology. So you mentioned that also. These three will quickly go. So I will know what is the audience, so we take it. Can you please pass on to them?
Hello, sir. Myself, Dr. Vishaling Rai. I am working as an assistant professor in the Department of Irrigation and Drainage Engineering. I am working on most of the remote sensing application in agriculture and also automation. We have one project on the lysimetric study in which we use the
thank you.
sensors for
Make it shorter if possible. Everybody has to go in 10 minutes.
Yes.
Just name and which department you are working. Any one project you are currently working. Only that.
Thank you.
If you don't have any project currently working, miss that also.
Hello sir, I am Sanjay Pawar, working as an assistant professor in Department of Agriculture Engineering, College of Agriculture, Burwan.
Okay. No need for titles also. Name is enough. Name something. And no need for professor, assistant professor not required. Tell me your discipline or what you are working and any project.
Yes.
Thank you.
Sir, myself Pritam Bhutada, working in sorghum crop as an agronomist.
Namaste sir, myself Dr. Sunita Pawar. I am an agronomist and my area of specialization is weed management and farming systems, and currently working in agrivoltaic project also. with GIZ. Thank you, sir.
Good afternoon, sir. Myself, Gaikwad Arun Ramarao, working at Department of Agriculture, Botany.
Good afternoon, sir. Myself, Bhosle Gopinath. I am pursuing PhD second year in plant pathology, and now I am working on purple blotch of disease of onion. Thank you, sir.
Good afternoon, sir. I am Salve Rahul, a PhD second year student, and I am working on cotton paste second.
Good afternoon, sir. Myself, Jadhav Vasant Govindrao. I am PhD Agriculture Economics. My PhD topic is Economic Impact of NICRA in Marathwada region in Maharashtra.
Good afternoon, sir. Myself, Bogil Yuvraj, Department Irrigation and Drainage Engineering. My research area is application of remote sensing.
Okay, myself Amol Kumbar. I am PhD first year student. My research topic is soybean mosaic virus.
My name is Chantanu Dhause and I am working on crop weather models.
नमस्ते सर, फिर से मुलाकात हो रही है, आपका परभनी में स्वागत है. मैं सेल्फ डॉक्टर मेघा and I'm working as an agronomist at Department of Agronomy, EMN Kilpa.
Myself Dr. Aniket Vaikar, I am working in Agriculture Engineering College.
Good afternoon, sir. I am Ravindra Shinde, working in the Department of Basic Sciences as an assistant professor physics. Thank you.
Good afternoon, sir. Myself, Dr. Anant Lad, working as an entomologist at Department of Entomology. Presently, I had 2 projects on e-pest surveillance. Recently, one DST project is also sanctioned. Thank you.
Myself, Dr. Milind Sonkamre, working as assistant professor of entomology. Area of research work is apiculture, rearing of honeybee.
Myself, Pashawar Swati Shivling. I am MSc second year student and research topic is calibration of infocrop model on pigeon pea crop.
I am Pardeshi Nikita, a PhD scholar in soil science department, and my research area on the mycorrhizae and PGPR, soil microbiology.
Myself, Achal Chaudhary, studying in MSc first year with discipline plant physiology.
Myself, Godavari Joshi. I'm from plant physiology department and my interest is biological plant systems.
My name is Nikita, PhD scholar from Department of Horticulture, and my area of interest is dragon fruit production.
I am Durga Ghandge, currently pursuing MSc in plant physiology, and my research topic is evolution of physiological traits in common bean under rain-fed conditions.
Myself Dipali Jadhav. I am second year MSc student and research work on genetic study of F4 generation in chili.
I am Sharda Durge, working on mutation breeding in sorghum.
I am Syed Shirin, a PhD scholar in agronomy department and currently working on designing synthesis and field evaluation of amino acid based micronutrient foliar fertilizer.
Myself Megharam Lukoturor. I am from agronomy department, PhD first year. My research topic is effect of crop residue management in pigeon pea based millet intercropping system and under the guidance of Dr. Asevarsu.
Myself Drupti Godera, Department Entomology PhD first year student, and my research is on screening of genotype of major insect pest of soybean.
I am Kayanjali from the Department of Agriculture Meteorology. I am the PhD first year student and my research work is on crop simulation modeling.
I am Dr. Asha Chauhan, working as Senior Research Assistant in Department of Agronomy.
Myself Deepak Shinde, I am working as a JRA in Seed Technology Research Station and I am working in breeder seed soybean production.
Myself Kadam Nitesh Venkat Rao.
working as a junior research assistant, BSP, Breeder Seed Production Unit, Sendrai.
Myself, Ram Ranir, research assistant at Department Plant Pathology and working on the project of the Biomix, a consortium of beneficial bioagents.
Myself, Vijay Shinde, from Plant Pathology Department. I am currently working on wilt and root rot pathogens related to soil-borne pathogens.
Myself, Niranjan Mai. I am from Agronomy Department. I am pursuing my MSc first year.
Myself, Kushti Akash. I am from first year student, MSc first year.
Myself, Bhale Sushant. I am currently studying in MSc first sem, Agronomy Department.
My name is Pragati Magar from Department of Agronomy.
My name is Anju Hendre from Agronomy Department. I am the MSc first year students. Thank you, sir.
Myself, Vaibhav Ramesh Shalke. I am Department from Agronomy.
Myself, Abhay Madhukar Rautare. Currently, I am pursuing MSc in entomology. I am a first year student.
I am Satale Bhima Shankar from Department of Agronomy, PhD scholar, and my research work is yield maximization and nitrogen use efficiency in BT cotton through nanourea.
Sir, myself, Ankush Venkatrao Khandre. I am the student of Department of Agriculture Extension Education, PhD students. My research area is, sir, socio-economic impact of climate smart technology on the soybean growers. Thank you, sir.
Good afternoon, sir. Myself, Dheeraj Madhav Kadam, a PhD first year student from the Soil Science Department, and my area of research is on remote sensing and GIS, sir.
Good afternoon, sir. Myself, Nishikanda Chavan, from PhD first year Soil Science Department. I am working on soil chemistry.
Good afternoon, sir. Myself, Shraddha Gondge. I am pursuing MSc Agriculture Meteorology. My research topic is effect of thermal regime on wheat genotypes.
Good afternoon, sir. My name is Harshada Bahasupandre, Department of Agriculture Meteorology, MSc first year student.
Sir, I am Satvik Panda, MSc Agrometeorology first year.
Myself, Praveen Kumar Prajapati. I am discipline Agriculture Meteorology, MSc first year.
Hello, I am Sushant Bhalerao. I am postgraduate student of Farm Machinery Department, and my current research work is on computer vision for pest detection. Computer vision for pest detection. Pest detection.
Hello, myself Gajanan Naik. I am pursuing PhD in second year. I am working on research project of VNMQV BARC collaborative research project on mutation breeding in sorghum.
Myself, Amir Singh, PG scholar from Department of Agriculture and Meteorology, and my research topic is assessment of DOP indices and rainfall based indices, mostly SP and DI.
Hello, myself Omkar Kakade, agriculture engineer pursuing a master in farm machinery department. I am working on automatic vegetable transplanter.
Myself, Hanuman Kadam. I am currently pursuing masters in Department of Genetics and Plant Breeding, and I am working on induced mutation on Rabi sorghum.
Hello, sir. My name is Shivam Bagal. I'm pursuing my post-graduation in Department of Agronomy, Parbhani. My research area is response of Jivamrut with and without FYM on growth and yield of sweet corn. But I'm also interested in nutrient management. So, thank you.
I am Radha Manohar Lolge, a PhD first year student from Department of Food Business Management.
Good afternoon, sir. My name is Priyanka Kali, PhD scholar, specialization in food technology.
Good afternoon, sir. Myself, Deepak Tate. I am pursuing MTech Food Technology, and I am currently working on development of value-added product from Mova flowers.
Good afternoon, sir. My name is Kishore Anero, PhD first year student from College of Food Technology, VNMQ.
Myself, Shendki Santosh Nagnathrao. I am pursuing PhD from the Department of Food Technology. My area of research topic is dragon fruit processing.
Hello, sir. I am Gajanan Guge. I have done my MTech in food technology. I have worked on probiotic yogurt, and now I am interested in how to overcome problems in food industry.
I think very interesting. You heard yourself, all of you. So much very discipline of agriculture. People are there. We are studying. We are assembled here. Of course, we have little bit groupism already. I find some meteorology people will sitting there and some agronomists together. That happens in the college time. Agreed. But when you get out of the college, I think it's all one. Farmer. There is nobody other than farmer you are working. Now, interesting is also from this session, I understood till now what work you are doing. Now we'll come back I didn't ask you how you started your topic, who gave the topic. Most of the time the professor gives the topic in many universities, I don't know about here. So, but we'll talk about it later on for a short while. Future should be how. You should, when you grow to the level, how to select the projects. Last year we visited IIT Kharagpur also spent about 2 days to talk with all the students. And so it was very interesting to know IIT Kharagpur produces I think the highest number of professors in agriculture engineering section, for example. So it's very interesting. And I want to ask you a question. How many of you in this, after you complete your studies, want to do business? Can you raise your hand? It's almost same, but ratio is higher. I remember asking the same question 3 years back in Rauri. Out of 400, something 3 raised the hand. And around 4 or 5 years back in TNU, when I asked, around 3, 4. Here is around 4, 5. That is out of maybe, but here is very less. Probably you have 100 also not there around the strength. So, but still higher percentage because 4% people. And have we ever imagined what happens to rest of them? We don't, right? We'll come back to address this also. How to address this issue. But more important first we're going to start after the lunch session is what is India agriculture? And especially we are in Maharashtra, we like to see the agriculture, how to make it, what are the climate problems we are having, how to make it smarter, which are all the techniques available. And we also will learn about what is the buzzwords used in simple terminology to understand AI, whether AI will be useful for me in a genetic guy. I may not understand fully, but whether I require AI or whether I require a machine language, where I require automation, where to put the sensors. So this, you will come to know each area. I know what areas you are working. So we will see that. And in detail, one of them who are interested to go, time is no problem, okay, according to me. I have come all the way for 1 day only from Mumbai and I'm willing to spend the whole time. And depending on but it must be interesting, okay, for you. I come all the way not to get a name for me. I don't want any more names in my life, okay. But I think it's to help you to understand basics. Pure basics we must understand. For example, deep diving, if you want to go AI, you have to be excellent in mathematics. Are you willing to spend time? Okay, I will tell you at least how much time you have to spend on each line. You can ask me blindly any questions because most of the areas I have worked or have good friends worked on it, and I'm a good voracious reader, so I also read about them. So that is my passion. So we will, I think, we are almost time for lunch. I don't want to hold you. Come back after lunch fresh. It's going to be a different session. So just now, one more advantage, you all came on the YouTube also recording, correct? All of you participated in the program. There is a very excitement. You can listen to this afterwards. Thank you very much. We'll see after lunch. Thank you.
Thank you, sir. Again, we are going to listen Dr. Ismail, sir, in the afternoon session. Our afternoon session will start sharp at 2:30. Okay. So now there is lunch break. All of you can go for the lunch at Naib and gather here at 2:30 for to listen Dr. Ismail, sir. Thank you.